Let Shivain also get enter in the class. Welcome, Shivain. All right, so I've pasted few links. I want all of you to open your chat section. First link is of syllabus link. You can check which all topics will be covered in your particular course in this subject under the syllabus on this link. In case you have not enrolled yet, no need to worry. You can still complete your payment process and you can join this batch. We are always welcome to take up the feedback. For that, you just need to fill up this feedback form. 1 second. And in case you want to know in detail about this particular course, for that you just need to click on this all batch detail link. And of course, we are always welcome to take up your queries. For that, you can email us at support@olympiadsuccess.com, or you can drop us a WhatsApp message on these two particular numbers. Okay. So with this, now I would like to invite your mentor at the platform. His name is Mr. Abhinav Ashish. He's been taking Olympiad classes since so long, and his classes are very engaging, interesting, as well as productive. So I'm sure you'll be going to get a fun-filled and productive session. So with this, over to you, Abhinav, sir.
Hello, everyone. I hope all of you are able to hear my voice. Hello. Hello, everyone. Okay. All right. So today we are going to be talking about heat chapter. All right. Let me share my screen. Is
Abhinav, sir, let
able
me have my
to
presentation, then we'll start with the demo.
okay, okay. All right, all right.
Yeah. Meanwhile, you can just introduce yourself to them.
Yeah, my name is Abhinav, okay, Ashish, whatever you can call me. All right. Uh, I'm taking classes since like the last 6, 7 years. Okay. I love students who are curious. Interacting with students, okay, and teaching them. It makes me happy. All right. And I'm sure that we are going to be having a lot of fun together in our classrooms. Okay. All right. Over to you, Pooja ma'am. You can.
Thank you so much, sir. So we got one more girl, Disha. Welcome, Disha. 1 second, let me reshare my screen. All right, so I welcome all of you at the platform of Olympiad Success once again, wherein we know that we are gathered over here for science demo. So we are India's largest preparation platform, wherein we have students from more than 5,000 schools and from 35 countries. So you can meet our rank holder on the screen. So they are kids like you only. No need to worry. You have your best mentor who will be taking up your classes. So you can also be the rank holder. For that, what you need to do, you just need to spare every 2 hours extra from your regular studies, that you can also be the rank holder. So what all do we offer? We offer School Plus program, including subjects mathematics, science, English, reasoning, Vedic maths, communication spoken and written. So we do offer one-on-one preparation classes for grades 2 to 12 for CBSE, ICSE, IGCSE, and IB boards, as well as we offer classes for International Mathematics Olympiad preparation. So that is SESMO, SEMO, HKIMO, TIMO, Maths Count, and so on. So what all you'll be going to get in these classes, it will be a group session for 75 minutes with 5 minutes of break. So 35 minutes, then 5 minutes of break, and 35 minutes. So class days will be Tuesday, Thursday, and Saturday. Timing will be it will be 6:30 till 7:45 p.m. with 5 minutes of break. So timing will be 8 p.m. All right. So it's not at 6:30. There was some confusion. So what all you'll be going to get, you'll be going to get a curriculum which will be available on the dashboard. Soon I'll be going to show you the same. So you'll be going to get your lectures with your seasoned tutors. So it will be a live session on Zoom platform with around 20 students with one mentor. You'll be going to get access of your daily reading material as well as previous year papers. So fees for this course will be 12,044 rupees. So live classes will be going to continue from April 18, 2026, right? So these are the relevant links for your course. No need to worry. Links have been pasted in the chat box. We'll again paste it over there in the chat section. So let me take you through our platform now, wherein you'll get an idea that how you can have access to your material. So here you come up on the platform. You need to enter this URL, olympiadsuccess.com. Over here, you'll be going to click on login. So you will be going to log in with your registered email ID. With which you will register on this platform. Okay. So I am entering with one of our demo account. After signing, you'll get your profile details on the screen. Check it. In case you find any error, you can update it over here. Just a second. It's taking them longer than expected. Oh, so here we go. So coming up on the course material, for that you need to click on online classes, click on course material, select your subject, select your topic, and here you can see the schedule in which you'll get the clarity in which session we are going to cover which particular topic along with your test preparation. All right. So in test discussion, you'll get a mock test paper, which you'll be going to solve it, and you'll get an idea that whether you have understood about that topic or you have doubts so that you can clear with your mentor. So in last, there are super classes. In super classes, you will be going to cover previous year papers for your practice. All right. Here you come up on the reading material. So here you can see the reading material. With this, you have a test paper, practice question sets. So you solve the paper and then check your answer keys. Right. So there is more practice that is under section of test series. Click on practice test. Select your subject. Click on take exam. Read instructions, tick this box. Click on start worksheet. Select this, click on next button. So once you have done all the questions, you can submit your worksheet by clicking on finish button. Yes, I have reviewed all the questions. So you can check your performance parallel in these worksheets, that how you have performed and how much you know about this particular topic. Okay, so the correct answer is C, I have filled B. So you can check your performance over here also, and you can see the explanation is also given for that particular question. All right, so you'll get to know about your schools. Yeah, so that's pretty much about it. Now we are open for the question answer round. So if you have any doubt, need a clarity, feel free to ask your questions in the chat box. Otherwise, we'll be happy to begin with your demo. Any doubt? Or shall we begin? Disha, Shivain, please turn on your cameras. Disha has joined from two devices. Is it so, Disha? One more child is there with the name of Disha. Okay. Any doubt or shall we begin? Okay. Over to you, Vikram, sir.
Okay.
1 second, sir. Disha, you can get the username and password with which you have made a registration on this platform. Okay. If you remember that email ID, that is your username. Okay. In case you have any doubt for the password, feel free to reach out the team. I'll paste the links once again for your reference. So there is a customer support number has been given in the last. So you can just contact them. Okay. So they'll be help you out for the email ID as well as password. Right? Anybody else? Okay. Over to you, sir.
Okay. I hope everybody can see my screen. Is my screen visible to all of you? Okay. So in today's session, we're going to be discussing regarding heat. Okay. I hope you have some previous understanding regarding heat and how it affects us in day-to-day lives, right? Okay. First, anyone can just tell me, what do you understand by heat? What is it? What does heat mean? Anyone? Shivan, you want to answer? What is the meaning of heat? What does it mean? What do you understand by the word heat? Nobody? Disha is saying high temperature. Okay. Okay. Akshara is saying hot vapor. All right. Shivan is saying heat is a form of energy. Yes. Okay. Heat is a type of energy. You know about energy, right? Okay. You know about energy? Heat is a type of energy. Got it? Now, temperature, what you said, somebody has said temperature, right? Hot temperature. Temperature is the measure of heat. Okay, Disha. Temperature is how we measure heat. If something is very hot or something is very cold, how hot it is, how cold it is, all of these things are measured, okay, by temperature. Temperature is a physical quantity for measurement, and how we measure temperature, that also we'll discuss. Okay, there are different measurement units like degrees Celsius, Kelvin, Fahrenheit, and all of these things. Now, heat means it is a type of energy. You have heard about so many different types of energy, right? Solar energy. Anything else? Solar energy, electrical energy. You have your wind energy, sound energy. So all are different kinds of energy. Yes, we get heat energy from the sun. Okay, we can also get heat energy from a fire. Okay, or an electric heater. Got it? Yeah, chemical energy. Yes, our food. Food contains energy stored inside it, right? And when we eat that food, that chemical energy is used by our body to conduct different activities. Okay. Hydroelectrical energy means, yeah, just the moving water from the rivers, it is converted into electrical energy. Okay, different kinds of energy I've heard about. Similarly, heat energy or thermal energy, we are going to be talking about. All right. Now, when you experience heat in day-to-day lives, okay, in winters, you want to remain warm. Okay. In summer season, you want to remain cool, isn't it? Or in summer season also, you want to sit in front of a fire. No, right? Our body needs to be cooled down in case of summer season, and our body needs to be needing warmth in case of winter season. So in winter season, what we do? We wear a lot of woolen clothes to trap heat inside our body so that our body heat is not lost to outside and we don't feel cold. Similarly, in summer season, we wear very light cotton clothes so that the sweat can evaporate and our body can cool down. Got it? So heat constantly is transferred, just like energy, just like other energies that we were now talking about. Heat is also a kind of energy which transfers, right, from one object to another object. So how does heat transfer? Does it transfer from a hotter object to a colder object or from colder to hotter? Tell me, Akshara, what do you think? From where does heat transfer? From which object to which object? Others also you can mention in the chat box. Yes. Sanish is saying hotter to colder. Yes. Yes. Hot to cold. Yes. Correct. Okay. So anything which is hotter in nature will transfer its heat energy to something which is colder. Got it? Now let us understand what this heat actually is. Okay. From particle perspective, all of you know about matter, right? Okay, we'll talk about a really interesting thing here. Everybody knows about matter. What is matter? Anyone can tell me what is the meaning of matter? What is matter? You must have studied about matter in your school in science. What is matter? Anything that has mass and occupies space, volume, can be called as matter. Yes, anything that exists. Okay, anything like the pen that I'm holding here. Okay, it has mass, right? And it is occupying certain volume. Anything that you see around you, okay, that has mass and can occupy some volume, that is called as matter. Now can your feelings be considered as matter? Okay, feelings of anger, jealousy, all of these things, can it be considered as matter? No. Can your thoughts be considered as matter? No. Okay, these things are abstract, they are not considered as matter. Okay, and matter is made up of particles, tiny particles. What are they called? Matter is made up of tiny particles. What are those particles called, students? Atoms, yes. Atoms and molecules, yes. Got it? They're made up of tiny particles called as atoms. And when those atoms combine with each other, they form molecules. Like water molecule. You must have heard about water molecule. H2O. It is made up of one molecule of water is made up of two hydrogen atoms and one oxygen atom, right? Got it? So these are all particles. So for now, we just consider them as particles. Okay. We don't consider them as just atoms or molecules. So forget about that. Let's just consider them as particles. So all matter is made up of particles. Clear? Now I'm drawing three particles, three types of matter here. You are going to be telling me which is which. Okay. This is the first one. Okay. This is second one. And this is third one. Okay. Can anyone tell me which is solid, which is liquid, and which is gas? Okay, let me write it as A, this is B, this is C. Okay. Which one is which? Tell me in the chat box. Okay. Matter A, matter B, and matter C. Okay, Disha is saying A is solid, B is liquid, and C is gas. Shivan is also saying A is solid, B is liquid, and C is gas. Okay, yeah, everybody is saying the same thing, correct answer. Okay. Now, can anyone tell me why A is solid? How did you know that A is solid and B is liquid and C is gas? How did you know it? How did you get it? How did you get to know that A, B, C, they are solids, liquids, and gases respectively? What is your reasoning behind it? Akshara is saying very tightly packed molecules. Yes, Shivan, Sanish. Okay, Disha, yes. Without any space, yes. Very good. Okay, correct answers, everybody. Okay, correct answers. A is solid because the particles are always in solids. What happens? They're very, very close to each other, very tightly packed. Yes, they cannot move from one place to another place. They can only vibrate. Those particles can only vibrate. They cannot move from one place to another place. But in case of liquids, they are slightly more there are slightly more gaps in between them, and those gaps are called as interparticle space. They're called as interparticle space. Okay. And in gas molecules, in gas particles, the interparticle space is very huge. It is very high. Those particles are very, very far away from each other. Clear? So that is gas. Got it? Now, what do we mean by another term I'm going to be writing on the screen? What do we mean by interparticle force of attraction? Anybody can tell me what is the meaning of interparticle force of attraction? Very just 2 3 words you can just tell me, okay? What is the meaning of interparticles force of attraction? The force of attraction between molecules or atoms, or force of attraction between particles. That's what you're saying, right? Yes, see students, all these particles, they have fundamental property and they pull each other towards themselves. Got it? All of these particles, remember, they pull each other towards each other. That is the reason they stay like that. Do you think my pen is going to fall apart randomly, automatically? No. Okay. It is because the particles inside this pen, they are pulling each other very tightly. That is the reason it stays as a whole. It does not fall apart. Okay. Same thing goes with water. Same thing goes with liquid also. But it has slightly less interparticle force of attraction. Here, these particles, they can move from one place to another place, but they still stay liquid, right? Do you see water flying away in your room? No, right? If you put water in a glass, the water stays inside the glass, right? Or does it fly around you inside your house? No. But when we talk about gas, this has the least amount of interparticle force, negligible, next to zero. That is the reason gas cannot be contained. Can you contain gas? Tell me. Can you contain a gas? No, it will fly around everywhere. It will not stay inside a container. Okay. It will not stay inside a container. It is free to move around everywhere. Got it? Because the interparticle force of attraction is very less. And remember, students, the further the particles go away from each other, the lesser and lesser and lesser the interparticle force of attraction becomes. And the closer and closer particles come towards each other, the force of attraction increases. Now, why I'm explaining you all this? It is all related to heat. Now, heat, students, it is an energy with which these particles vibrate or these particles move. If I say, students, that this pen that I'm holding is very hot, it means the particle inside this pen, the particles inside this pen, they're vibrating very fast. Okay. Now, if I keep this pen in the fridge, what will happen? The vibration will stop, not stop exactly, it is going to reduce. Okay, because heat is taken away from it. Okay, now let's take an example of ice, water, and steam, and you will be able to understand how heat actually affects change of state. Okay, let's say I have an ice here, ice block. Okay, its molecules will look like this, right? The particles of ice will look like this because why? Why do they look like this? Because they are tightly packed. It is a solid. Ice is a solid, right? So its particles, they look like this. They're very close to each other. Interparticle forces very high. Got it? Now, what will happen, students, if I start warming this ice, if I start heating this ice, what will happen? What will happen? What will that heat cause? What will happen to those particles? What will that heat cause to happen? Hmm? It will melt. Everyone knows it will melt. Okay. All right. Yes, of course it will melt. But I'm asking what will happen to the particles? Disha, yeah, it is going to melt. We know that. Okay. Yes. The answer that I'm yes, Sanish, very good. Particles will start moving away from each other. Yes. Particles will start to move away from each other. Why? Because the moment you supply heat, what will that heat do? We just now talked about, right? What is heat? Heat means how fast the molecules are moving, how fast the particles are moving. So when you supply heat, listen very carefully. When you supply heat, what will happen, students? These particles will start to get very energetic, very excited. They will start to vibrate more and more and more. All of you able to get my point? Everybody? Okay, give me a thumbs up if all of you are able to understand what I'm trying to tell here. When you apply heat to those ice particles will start to vibrate faster and faster and faster. Okay, a time will come when they will vibrate so fast that they will break free of their bond. That interparticle force we were talking about, they were very close, no? They were very close. So they will vibrate so fast that they will go away from each other. They will move away from each other and they will turn into what? Water, liquid water. Clear, everyone? Because these particles have gained very high energy. They are very, moving very fast from each other. Now, what will happen if I further heat it? If I give it more heat, if I give it more and more and more heat, what will happen? The same thing will continue, na? The exact same thing will continue. These particles, how fast they were moving, they will be moving even faster, right? They will be moving away from each other even faster. So again, at a time will come when they will move so fast away from each other that they will turn into gas. They will move very far away from each other. Those molecules, those particles will move very far away from each other and they will become gas. All of you understood how heat affects this? All of you understood what is heat? How heat actually is defined? Heat is nothing, students. Heat is nothing, just how fast the molecules are vibrating, how fast the particles are vibrating. Okay. If somebody tells you that this object is very hot, it means you just have to imagine that the particles inside those objects are moving very fast, vibrating very fast. They have high energy. Got it? Now let's take the reverse. What if I cool this gas? What am I doing? If I cool this gas, I'm taking away all of their excitement, right? I am taking away all of their energy. If I take away all of their energy, they will come closer. So when they will come closer, they will become liquid. Got it? When I put this liquid inside the fridge, and if I take away more and more heat, those liquid particles, the water molecules, they are no longer excited, right? They will lose all their energy. So they will all come even more closer and closer and closer until they become ice, which is called as freezing. Okay. Gas to liquid is called what? Liquid to solid is called as freezing, right? Gas to liquid is called what? Gas to liquid will be called as conversion from gas to liquid. Condensation, yes, condensation. Water will condense. Clear? Yes. Akshara, space will reduce. Yes. When you cool, it means you're taking away their heat. You're taking away all their energy, right? So the particles will come closer and closer and closer. And I told you, right, that the more the particles come closer, the interparticle force becomes what? Increases or decreases? If particles come closer and closer and closer to each other, the interparticle force between them, the attraction force between them increases or decreases? Increases, yes. The closer they come, the force will increase and they will hold on to each other and become liquid, right? And if you further take away heat, if you further cool them down, they will come even more closer and become solid. All of you understood how solid becomes liquid, how liquid becomes gas, and how reverse happens, liquid to solid and solid to gas. Sorry, gas to liquid and liquid to solid. All of you understood this. This is very fundamental thing that I'm talking about. Okay. Questions can come regarding this. Clear, all of you? Now, let us move forward. Okay. Back in the game. Limits of human sensation. Sensation of hotness and coolness. It depends entirely on direction of heat flow. Okay. Heat flow direction, it determines whether you are going to feel hot or whether you are going to feel cold. Got it? Now, let me ask you a question here. When will you feel hot and when will you feel cold? Acha, first of all, tell me, anybody can tell me what is the temperature of human body? What is the temperature of human body? Anyone? Normal body temperature. 37 degrees Celsius. Yes. Or 98.6 degree Fahrenheit. Yes. 37 degrees Celsius is the human body temperature. Now, when are you going to feel hot and when are you going to feel cold? Tell me. If 37 degrees Celsius is normal body temperature, when will you feel hot and when will you feel cold? Easy question. Yes, Anish. Okay. If the outside temperature is more than this, then you will come to be feeling hot. If it is less than this, you're going to be feeling cold. That is the reason why you feel very hot in summers and really cold in winters, isn't it? Clear, everybody? Okay. Now, human touch. Do you think human touch is a reliable method for recording temperature? No, right? Can we touch every object and check whether it is hot or cold? Can you touch a boiling object? Okay. No, you can't do that, right? So human body has limitations. We can't touch a body which is too cold or we can't touch a body which is too hot. Okay. And we will talk about that, okay, regarding temperature and thermometer. Don't worry. Now, heat is a form of energy that flows from a hotter object to a colder object. Okay. Examples are written here. Very simple, sun, fire. Okay. Your cooking stuff, all of them, they are sources of heat. They're of very high temperature. Got it? Objects with lower heat content, like ice, cold drinks, winter air, it means that the molecules are not vibrating that fast. The molecules have low energy. That is the reason why they are called as lower heat object. Whoever is having higher heat means the molecules or the particles inside those objects, they are vibrating very fast. Clear, all of you? Okay. Now, distinguishing heat from temperature. Students, I have already told you that heat is just energy. Temperature is a way to measure that energy. Got it? Temperature is a way to measure that energy. Clear, all of you? Got it? Now, let's say, I'll give you an example. Let's say distance from your school to your home, okay, your height, okay. All of these are physical quantities, right? But how do you measure it? We measure by measuring its length, right? We measure it by measuring its length. Length is a physical quantity here. Similarly, heat is the energy and temperature is a way to measure that heat, how hot or how cold it is. Okay. Temperature is a measurable effect of that energy transfer. You can see here. Okay. If you heat, the particles you can see they are moving very fast. You can see here in this diagram, the particles are moving very fast. And if you put a thermometer inside it, a thermometer can determine how hot or cold that object is. Clear, everybody? Okay. Now, there are two kinds of thermometers. Technically, three kinds. Okay, but we'll talk about for the first two kinds. One is a clinical thermometer versus a lab thermometer, a laboratory thermometer. Okay. Can anybody tell me the difference between clinical thermometer and uh, laboratory thermometer? Anyone? In the name itself, it is there, right? What is clinical? Clinical means must be used in clinics. Laboratory thermometer means should be used in laboratories, right? That is what you mean to say. Yes. Clinical thermometer, student, it is used for measuring our body temperature, our human body temperature or your pet's body temperature. Okay, you have thermometer in your house, right? Okay. Its range is from 35 degrees Celsius to 42 degrees Celsius. Because this is the range minimum and maximum that your body temperature is going to be. Not less than this, not beyond this. If it becomes 42, you are dead. If it becomes 35 also, you are dead. Okay. 35 is too less and 42 is too high. If it goes beyond 42 or less than 35, okay, goodbye. Got it? So the range of clinical thermometer is from 35 to 42 for measuring the temperature of your like humans and your pets, okay, in vet clinics and everything. The laboratory thermometers, it is used in chemistry labs. How many of you have been to chemistry labs? Do they allow you to enter into the chemistry labs in your school? Or do they not allow? That is only for the big children. Okay, anyways, in chemistry labs, you'll see a very long thermometer, okay, whose temperature range can range from minus 10 degrees Celsius to 110 degrees Celsius. It can measure the heat energy of water or other chemical reactions which is being performed inside the lab. That is the reason why its temperature range is so high. Clear, all of you? Understood the difference between clinical thermometer and laboratory thermometer? Okay. Yes, Disha. We can use it to measure boiling point, freezing point. That also we'll discuss in further classes. Got it? Now, what if I use clinical thermometer to measure uh, temperature of chemicals in lab? What will happen? Do you think it is going to be able to do it? No, not possible. It will break. Got it? It is going to break. It was not going to be able to measure it. That is the reason why we are going to be using laboratory thermometer in chemistry labs. Okay. Yes, it should have a wider range. Yes, Disha. Got it? Yes, it will burst. And why it is going to burst, we're going to be discussing, okay, in further sessions. All right. Okay. So I hope all of you enjoyed today's session, right? Since this was demo. Got it? We talked about what is heat. We also talked about a really important concept. Okay. We talked about a really important concept, that is how solids, liquids, and gases, their particles interact. All of you understood that concept, right? While heating solids, the particles, they move away from each other, they become liquid. If you heat it even more, the particles even go further away from each other. So they will become gas. So gas, if you cool it down, if you absorb the energy from the gas, it will turn into liquids. And if you further cool it down, if you further take away the heat, they will come even more closer and closer and become solids. Clear, everybody? Okay. Temperature is a way to measure how hot or how cold something is. Okay. And we have thermometers for measuring temperatures. Got it? Two different types of thermometers also we discussed. Clear, all of you? Okay. So I hope all of you enjoyed today's session. Okay. I hope we will see each other soon again in further classes. Okay. All right. Bye. Bye, everyone. Have a nice day.